Welcome back for the next video where we're going to work on this blaster weapon, and we're going to try to give it the ability to hold down the mouse to charge it to get a more powerful bolt out of it. So we will start, we'll start with actually just getting the charge mechanic to work, and then we'll work on providing some kind of visual feedback to the player that it is being charged. So let's go up to the variables and begin to add a few things here. So we've got time between attacks at 2. So for the sake of just argument, let's bump that to 3. Now, this is a public variable, so it's not going to automatically update. So we'll just do that. I'm going to take out that comment there. Now we need a charge, like how much time does it take to reach to max charge? So we'll add this here, public float, whoops, and I'll call this charge max time, and we'll make it at 0.4. So what this is, how many seconds does it take to read? Oh my goodness, my typing is done for the day. How many seconds does it take to reach a full charge? Okay. Other things that we might need here. We are going to need a few more variables down in this internal variables. So we're going to need a is charging. And we'll start that off as false. And that's all we really need. Oh, we need a charge. So just an idea of how charged is the weapon. And we're going to measure that in seconds. So similar to what we did with the aim down size ratio, but slightly mathematically different. Now I don't have a good sound effect for charging, so I will point out that typically how you'd want to do this is when you press fire 1 down, play a sound effect for charging. And we would stop that on release when we release the key. But that's actually all we would do in fire down. We're going to eventually, well, I guess we'll do the code for when we first when we start charging this weapon. So so we'll start adding that code there. So if the cooldown is 0, then we're able to charge. Oops. So if we're holding the key down, we want to set is charging to true. And then charge plus equals time.delta time. And we will cap charge. So we will cap the charge by using math.max. Or I'm sorry, math.min. So it'll take the minimum of these. So charge starts at 0. We get like 0.1 from time.delta time. Max time is like 0.4, and it'll choose 0.1. And up until we become too powerful, then when this becomes 0.5, it's going to choose the max. So it caps us. It's a elegant way to handle capping. Now, we could have merged these two lines. That's just a style thing. So additionally, we could use the isReady command. I guess we could use isReady there. So let's take this And I'm going to cut that for now. We're going to come back and we're going to move that elsewhere. So we're going to move that into fire up. So I'm going to minimize fire 1. I'm going to open up fire up. And I'm going to paste it in here. So when we release the key, basically we should only do something if the weapon is ready and we are charging. So we will spawn my laser. We initialize it. Oh, my cats just got super excited. And not much of this needs to change. I will point out that we would want to stop the charging sound effect there, but I don't really have that sound effect. But that's where you'd want to do it. So after we spawn all of this, we would want to clear the charge. So charge equals 0. And then is charging is set to false. Additionally, we might want to just set is charging to false on release, and actually probably do both of these down here, just on the off chance that for some reason the weapon becomes not ready, and when we release, we just want to clear all that. So we could apply some calculations to the projectile speed. So we'll call this modified speed. And that could just be the projectile speed times some kind of bonus. So 1 plus charge over charge max time. Same thing for damage. Now, I haven't really truly thought this through. It might actually need to have a stronger modifier on the charge, because, in terms of damage at least, if we could do the math on the DPS, because it takes 0.4 seconds to charge, but only 0.3 seconds to attack. If you double the damage, you're actually getting less DPS out of a full charge. So you might need to triple the damage to get a more ideal DPS. So what I would do in that case is just do 2 times charge. Or what we could do is actually just make another variable here. And this is how much bonus damage. And you can kind of read the description there. So the speed can get up to doubled, and we will apply this. So charge bonus damage. I think we can do range on this. Whatever. So the minimum value you can assign it is 1, which would be atrocious, but whatever. If they choose to assign it to 1, that's their business. All right, so that's a better thing, and then we'll use modified speed as what gets initialized into the projectile. So this should give us a chargeable attack. We don't have any sort of other visual confirmation about how much charge we have in the weapon, and we'll add that in a second. The best confirmation we have is, and actually we could spit out the damage just for debugging sake. So we can print out the modified damage just so we can see how much damage we were supposed to be doing. And so now, if you just tap the button, it shoots like normal. And you can see if you tap it, you get like about 12 damage or so. If I hold down the key and then release, I get a 30 damage shot. And, you know, of course, we can always think about, like, do we need to make the charge time longer? But that's a balanced discussion. And, like, at what formula do you want to use? We're just using linear. A curve might make more sense, like a logistic curve might be better. I don't know. There's a lot we could think about. But I'll leave that for you guys to play with whatever math you're most comfortable with. Right now, it's just linear. I can say that you would want to consider different styles of still a video of computation for it. So, sorry, I lost my train of thought there. We want to now give some kind of visual feedback to the player, because right now they actually don't know how much charge is in this weapon and is it ready. Like, when do you reach the max charge? So let's go and start implementing that. This is a lot trickier, and this is a little bit more headache-inducing. So we'll want to visit the weapon prefab for some of this. And I guess while we're here in the weapon prefab, playing with all these settings, we can attach the crosshair. So you can just pick a crosshair out of the textures UI list here, whichever one you think makes the most sense. We won't see that for a couple videos, but at the very least, we could still pick a crosshair. Okay, so let's double click this so we can look at my blaster. Now I'm going to turn off the gizmos because the gizmos do make it kind of hard to see what we're about to do. And this asset was designed for these little pistons to be able to come out. So like if I click on it and drag it up, you can see that it was designed to do that. Now it is a little bit tricky which values we play with. So that's where we're going to begin working with, and we're going to have to copy these values out and remember them in an array, honestly. So let's go over to Visual Studio. And under, what would this be? I'm going to kind of put it under the internal bindings. Okay. So we'll say the position of the pistons. And this will be a private vector 3 piston start. And let's declare us an array. Now, to make this easier, there's a really cool thing we can do. So piston socket 1 has the values that we're going to manipulate. If you right-click them and go to copy, you can then go over to Visual Studio, and when you hit paste, it pastes it in as a vector 3. So I don't have to type those numbers in. I do have to put an F at the end of all those. And then I just hit comma, and then I can put the next one. So piston socket 2. We're going to copy that, bring it over here, type in new, paste it, hit a comma, put F at these so that it has those. Piston socket 3. Copy. Paste. Comma. Put an F at these. And our final one, piston socket 4. Copy these. And then we can, we're good with that. So we've created an array of the piston positions. So that means we are going to need to record these pistons. So public game object array of pistons, and we're going to bind those in the prefab. So semicolon there. Now we need a piston end, and this is where it's going to be a little bit trickier because we've got to position those ourselves. So we're going to get these by jumping back over to here and then pulling all of these out. They're really, I mean, we're just going to have to eyeball it the best we can. So that appears to be a good location for socket 1. So I'm just going to copy that, bring it over, and paste it. Now they got that rounding error going on here. Then I'm going to hit Control Z to bring it back. I'm going to click on piston 2. I'm going to, move my camera around so I get a good angle on this. Kind of hard to do because it is so far zoomed in. And bring it up as much as I can. Copy the position. Go over. Paste it. And then clean it up. Now, looking at this, you can kind of start seeing a pattern in the numbers. And so you could try to make it as numerically symmetrical as possible. So for example, like that's probably good at 14, that would be 8, and that would be 15. Something to think about. So piston 3. Copy these values. Go back over, paste them. Clean them up. Look at them. Reflect on what maybe would make more sense. Maybe this would be nicer as 55. And this might be 15. And honestly, we could probably conclude the last values just from pattern matching. And so that, I think, would be the last values. So if we save our script, we can then bind the pistons. They do need to go in the correct order, so you do need to be very careful about this. So where it says pistons, I'm going to make this a size 4 array, press enter. And now it gives me 4 slots. So piston 1 goes into the first slot, piston 2, piston 3, and piston socket 4. So be very careful. You need to make sure that you're using the piston, not the weapon container. Otherwise, it will not work right. All right. So now that we've done that, we should be able to then program this behavior that we need. And we're going to handle that using the is charging. So if we go down to update, right after we clamp everything, we will want to address the positions. So we'll say if is charging, then we're going to loop through all of the pistons. So we'll use a for each loop for each game object piston in pistons. Be careful about your plurals here. We're going to calculate the piston height as the value of the ratio of the charge to the max charge time. Now we do need a new variable here. So I'm going to put in one more array. And I'm going to call this private vector3 last piston height. And I'll just instantiate that as a new array inside of awake. And it's a size 4 array. So that way we can just assign it some good old comp sci 1 right there. So as we're going through this, we're going to then remember the last piston height. So, oh, I guess I shouldn't use a for each loop because I need to know what index I'm in. Ugh. There we go. So last piston height at index I will be set equal to a vector3 dot lerp. So again, using that lerp command, piston start at position I comma piston end at piston I using piston height. So then we'll just say pistons bracket I dot transform dot local position equals last piston height at I. So pretty crazy. Then we will do an else. So if we're not charging the weapon, we should be releasing these pistons, letting them go back down to their starting position. So we can base that off of cooldown. Not always the greatest, but still. We'll copy this loop. And paste it under the else here. So we don't need to recalculate piston height, and we don't need to store last piston height. So we're just going to update the local position of each piston to be and we'll just steal this vector3. Will be equal to a vector3 lerp from piston start. Now, instead of piston end, it'll be last piston height. And we're going to calculate a ratio. We'll make it a variable there. So this actually works in reverse. The cooldown ratio will kind of pick up, well, it'll start at 1 because cooldown will initially be equal to time between attacks, but cooldown will then decrease down towards 0. So it'll start here at the last piston height and then go back towards start. And this is actually why I didn't use the animator, because the animator can't really pick up from where you left off. It can, but it's well beyond the scope of my skills with the animator. All right, so we can save that. And let's test it. So let's double check, make sure all this stuff is attached. There's nothing we need to change here. Actually, if I recall, didn't I change one of those? No. Max charge time between attacks was 0.3. Yeah, that seems reasonable. All right, let's see what happens. So now you can see that all the pistons come up as I'm beginning to, and depending on, even if I just tap it, you can see the pistons pop up and they pick up from where we left off on the charge. So now the player knows how charged of a shot they have. I know, the weapon looks kind of silly, but and now if you wanted to play around with this, you could make it more complex where one piston fills, and the next one fills, and the next one fills, and the next one fills. That would be totally cool. But I just wanted to show the general concept of getting the weapon model to react to one of the states. And so that's pretty cool. Now the very last thing we need to do is put some kind of hit signifier so we know that when my blaster is finished, when the blaster hits something, we can get some visual confirmation on that. So I think the fastest way to go about doing that is to create an empty game object, and I'm going to call this Spark. Maybe more specifically, I'll call this Blaster Spark. And then I'm going to turn that into a prefab. So I'll turn it into a prefab in the projectiles section. But before I do that, let's reset this position. That's a crazy position. And we're going to bring it down here, so I can delete it out of the world. So Blaster Spark is right here. It has nothing on it. What we want to do is emit some particles out of it so that we can get some kind of visual that we hit something. So we're going to do what we've done. We're going to add a particle system. That is not what we want, but we can tweak it. First up, go down to renderer. We want to go find that material that we made. I'm just going to reuse that same spark. The starting color will be some kind of green. I really should have looked at what color that is, but the emission, I want to use a burst. The shape is going to be a cone, but let's turn gizmos back on. So I want to make the radius a lot smaller, so they're all coming out of that bump right there. Simulation space will be world. Duration can be maybe 2. Lifetime, these don't need to hang around. Let's keep it at 2. The speed, maybe 1. But actually, I think random between 2 constants would work pretty well. Between 1 and 2. So it looks like kind of sparks are getting thrown out. And then give them a gravity. And so that seems like that could be good. I maybe make them a little bit smaller. Start size. 0.1, no. That's too small. 0.4. That seems better. Okay, so we've got a little spark here. Now, we could probably manage deleting it from when we spawn it. So I'll back out of this. And for my projectile, there's a slot on my script for hit effect prefab. And so I'm going to bring in the blaster spark and open up the script, wherever that happens to be. Projectiles. So we want to trigger impact, but also right when we impact something, we want to spawn that hit effect prefab. So we'll instantiate the hit effect prefab at this transform.position and this transform.rotation, and then spark.transform rotate so that it rotates 180 degrees, because it's going to spawn it at the same facing as the projectile. Now, we probably would want to calculate the normal to the impact, but that's a little bit of physics that's not really worth getting into. So now when we hit things, we get this little satisfying bit of particles. Oops, I forgot to delete it. So when we spawn it, we also want to use the destroy command. If we say destroy spark, but then put a comma, we can specify how long to destroy it after. So the animation was set for 2 seconds. So if we say spark at 2 seconds, it will delete the sparking effect after 2 seconds. And so it won't play in a second loop. And so we've got our cool blaster. And we will get a chance to play around with that against some enemies in a little bit. That will be our chapter 3 goal. The rest of this chapter, I want to try to take a look at doing hit scan weapons next. So that will be the shotgun weapon. And then I want to take a look at doing a area effect rocket launcher type of weapon, which will be our 3rd weapon. And if I start switching over to those weapons, you can see I get some null reference exceptions, which breaks my script pretty badly. So we're not ready to switch to those weapons anymore because we need to write the scripts for those. But we'll take a look at hit scan weapons next. The final video in this chapter will then put a basic UI so we can track ammo and energy and health, and then we'll be done. And we'll move on to enemies next. So thank you for watching, and I hope you learned something pretty cool.